What about human origins? The heart of intervention theory is its position that humans definitely and beyond any doubt did not evolve on Earth. And, once we became established here, by whomever or by whatever established us, we have since done no more than microevolve into our fully modern form. What is the evidence in support of this radical theory? It comes in two general categories, the physical indications and genetic indications. Let's examine both of them in a bit of detail. Physically, humans supposedly have evolved, or descended from a common ancestor that we share with chimps, diverging at 5 to 8 Maya. If that were actually true, we should share many, not all, but quite a few, of the chimp's most fundamental physical traits. However, when we look under the hood, so to speak, what we find is little in common beyond having 97% of the same genome, our individual gene pools. For people unfamiliar with genetics, that 3% differential sounds trivial because they don't realize our respective genomes contain over 3 billion nucleotides, also called base pairs, or BP, so 3% of those would be 90 million BP. If you know what you are doing in a genetics lab, 90 million BP can be a lot of room to roam. The enormous physical differences between humans and chimps should make it clear to any person with an open mind that someone knew how to make good use of those 90 million BP. Here is something else to consider in terms of that 97% genome similarity between humans and chimps. Humans have 70% the same DNA as rats, 65% the same as mice, even 25% the same as single-cell, insensate, mindless yeast. There are 12 major, and many more minor, physical differences between humans and the higher primates, HP, like chimps and gorillas. Let's examine those 12 differences in detail. 1. Locomotion. This is the most obvious. We are bipedal and HP are quadrupedal. This is as different gets. Enormously so. 2. Skulls, and brains and skulls. Here, too, the differences are glaring. HP have brains that are massively reduced in mental capacity compared to humans, and they are also reduced in size. Above shows that a cerebral cortex, the surface covering of any brain that handles much of its mental workload, is the size of a postage stamp in rats, a postcard in monkeys, a sheet of typing paper for chimps, and 4 sheets for humans. Each case extends well beyond evolutionary transition. It is a transformation, likely more attributable to terraformers than to evolution. As for the skulls, all HP, and all pre-humans, for that matter, exhibit the same skull features. Below is a gorilla, top left, human, top right, and 3 pre-humans across the bottom row. All of the HP and the pre-humans exhibit, A. Thick, heavy, protruding brow ridges. B. Foreheads that recede straight back from the heavy brow ridges. No vertical foreheads. C. Large, round eye sockets that will have eyes capable of some degree of night vision. D. Wide nasal openings, which indicate their noses were as broad and flat as all HP today. E. Mouths pushed outwardly away from the face, protruding in a prognathous fashion. F. All HP and pre-humans lack chins, which is a universal trait shared by other primates. Human skulls are exactly the opposite of each of those traits, exactly 180 degrees opposite. All humans have greatly reduced brow ridges above greatly reduced eye sockets, which rest below a vertical forehead. Our nasal bones rise up to varying degrees to lift our noses up off of our faces so we can go underwater without the water gushing into our noses. HP can't do that. Humans have chins that are the exact opposite of HP's chin area. Likewise, human mouths are pushed much flatter against the face than HP's. These differences could not be more dramatic. 3. Bones. We have already learned the major difference in HP bones and human bones. Our bones are much thinner and lighter than typical primate bones. If we did indeed evolve to the condition we are now, where was the adaptive advantage in becoming so much more fragile? 4. Muscles. As we also learned earlier, human muscles are 5 to 10 times weaker than muscles in all HP. Where was the adaptive advantage in becoming more fragile and that much weaker? How could it make us better able to compete? 5. Skin. Light-toned skin is not well adapted to sustain direct sunlight. Even those with dark skin will eventually suffer adverse effects from sustained exposure with no relief from shade or using clothing. All HP have full body hair that protects their skin from unlimited sun exposure. 6. Adipose tissue. We have 10 times as much fat beneath our skin as HP have. When they are cut severely, their skin will pull itself together and heal as if a doctor had stitched the wound. If we are seriously cut, the fat under our skin pushes the wound edges away from each other. Without stitches, serious cuts become infected, which throughout history usually meant death. Where was the adaptive advantage in that? Most animals on Earth lack adipose tissue, so their cuts heal as easily as higher primates. The exceptions are sea-dwelling mammals, which have varying amounts of adipose fat to provide insulation, which it also provides for humans. 7. Body hair missing, pattern reversed. We lack the thick hair pelts of HP, and the patterns of growth on our bodies are the exact opposite of theirs. HP hair grows thickly on their backs and lightly on their fronts. Human males are thicker in front than in back. Human females have no heavy torso hair. Why and how would evolution engineer such an extensive switch? 8. Head hair and nails. Primates have head hair and nails that grow to a prescribed length for each species and then stop. They never have to trim either. So, why would humans grow hair and nails that must be regularly trimmed? Once again, where is any adaptive advantage in this? 9. Throats. Total rearrangement. Primates can eat and drink while breathing. Their windpipe is separated from their esophagus. Humans can't do it without choking, possibly to death. Once again, this would not seem to hold any adaptive advantage for humans, yet somehow we have it. Number 2, above, noses. The extensive redesign of the human skull permits our nasal openings to submerge and water won't pour into our throat. HP are not as fortunate. When submerged, the sharp in and downward angle of their nasal openings lets water gush in to choke them. 10. Sex. HP have obvious estrus cycles, while humans do not. This is a momentous change on several levels, moving us extremely far from all HP in this vital aspect of the life of any species. 11. Genetic disorders. Most animal species, including the HP, have relatively few genetic disorders spread throughout their gene pools, from a few dozen to a few hundred. Many of those cause non-fatal afflictions, like albinism, which are passed to offspring without harm. Severe genetic disorders tend to be weeded out and kept from the gene pool of all the natural species, non-domesticated. Humans, however, carry over 4,000 genetic disorders, from mild to severe, and new ones are found regularly. A couple dozen of those disorders kill all who express them before they can reach puberty to pass them on. So how did those get in our gene pool in the first place? How can they replicate from generation to generation, among every race and creed and culture on the planet? That answer is well understood. They replicate through passive carriers, to first initiate the genetic defect as a mutation, but in whom it is silent and does not harm them while they live. However, if they mate they can pass it on. Thus, one deadly defect can appear in a random individual, then gradually it can be passed on to enter the gene pool. It happens all the time. But now comes the problem that is hard to explain. If we humans are a recent species, less than 6 million years old, why do we have so many more terrible mutations than many far older species dating back tens of millions of years, such as rats or opossums or even our friends, the coelacanths? The mainstream can't answer this, but I'll take a stab at it in the next section.